As pointed out by some students that there has been some issue in the previous video for last couple of minutes, so I am recording a separate video for this, and this way I will revise the ANN again. So we want to realize AND gate using neural network. So AND gate has a simple AND gate has two inputs. We denote that by x1 x2, and there will be an output, and we also will have here a bias input, so basically +1, so this is actually x0. Okay, so this will also be treated as the input. It has been discussed in detail during the linear regression that why we represent this as separate x0, this bias input. Anyways, now what is our purpose? So first of all, what is the relation between x1, x2 and y? If y is the output, it is x1 and x2, and we know from the basic knowledge of gates that the truth table of AND gate is something like this. Okay, this is well known. Now we want to train neural network in this way. So what is our hypothesis function? We know that it is sigmoid function minus theta transpose x. Okay, and what will be theta transpose x? So let's write theta will be here, let's say theta 0, theta 1, theta 2. Since we have only two layers, we will not complicate the notation here. We write simply theta 0, theta 1, theta 2, and x of course is x0, x1, x2, right? So h theta of x is 1 divided by 1 plus e to the power minus 1 plus theta 1 x1 plus theta 2 x2. So actual problem is to find these weights theta 1 and theta 2 such that this neural network mimics the AND gate. But let's take some dummy values by this is a hit and trial, just by guessing. See what you want. We want to create this type of truth table x1, x2 and h theta of x. Fine. We want to mimic the AND gate, so 0 0 should give us approximately 0 here, 0 1 should also give approximately 0 here, 1 0 should also give approximately 0 here, and 1 1 should give approximately 1 here. Now if you look at this h theta of x, okay, now if you want 0 0, so what will happen when you put 0 0? So this will become before that I have made a typo, so it is here theta 0, sorry. Okay, fine. So basically it is theta 0 x0 plus theta 1 x1 plus theta 2 x2, but this bias value x0 is always 1, so it becomes theta 0 plus theta 1 x1 plus, so this is here correction, there is this theta 0. Now we need to learn about theta 0, theta 1 and theta 2 such that this neural network behaves like this. Now what should be the value? So x1 x2 is 0, so it becomes 1 divided by 1 plus e to the power minus theta 0. Now you want this to be 0, so for this to be 0, you see exponential is negative of theta 0. I want this term to tend to 0. It means the denominator should tend to infinity. For denominator to tend to infinity, e to the power minus theta should grow. E to the power minus theta will grow only when the exponent is positive and very large, hence theta 0 should be negative. Okay, so this is the motivation, and some large value. So we just pick up some minus 30 as the value of this. Now what should be theta 1, theta 2? For observing what should be theta 1, theta 2, let's take the last case when x1 x2 is 1 1. So when x1 and x2 is 1 1, what is the value of this hypothesis function? E to the power minus, so now theta 0 is minus 30 plus theta 1 plus theta 2. You see what is the target? The target is that h theta of x at this point when x1 and x2 is 1 1, it its value should be approximately near to 1. Now this type of expression being nearer to 1 means this term should vanish, this term should be nearly equal to 0. For exponential term to nearly equal to 0, the negative exponent must be very large, so this term should be positive and large, so that minus is outside. Now we have minus 30 here, so theta 1 plus theta 2 definitely has to be greater than 30, because when it will be greater than 30, then only there will be e to the power some minus positive quantity, so that will vanish. So we choose theta 1 theta 2. Suppose we choose theta 1 equal to theta 2 equal to plus 20, so that this becomes 1 divided by 1 plus e to the power minus 30 plus 40, which becomes 1 divided by 1 plus e to the power minus 10. E to the power minus 10 is very small, we can neglect, hence it is nearly equal to 1. And then you check other values. Suppose x1 is 0, x2 is x1 0, x2 is equal to 1. So what is the value of this hypothesis function? E to the power minus, so this is minus 30. x1 is 0, that term will vanish, plus x2 is 1, so theta 2. Now if theta 2 is chosen to be 20, so minus 30 and plus 20 becomes minus 10, so this becomes 1 divided by 1 plus e to the power minus of minus 10, that is plus 10. Now e to the power 10 is a large quantity, and hence 1 divided by this whole thing will be nearly equal to 0. So this way you can see that if you chose a neural network like this with theta 0 being minus 30, theta 1 theta 2 being 20 both, then this neural network behaves like AND gate. So that was the part which was not clear in the previous video. Now this is the exercise for you, and you have to, it's very easy. Now similarly try to mimic OR, XOR, NOR, NAND gates, and whatever gates you can easily see. These are the basic gates, it is sufficient. Just look into what should be the value of these thetas, so that the neural network behaves like these gates. Thank you.